Hello everyone. This will now be our lecture on balancing chemical equations. And it's a follow-on to what we discussed last night about translating and writing unbalanced chemical equations in the first place. All right, so when we're talking about balancing a chemical equation, um, uh, what we have in a chemical reaction um, is a set of compounds that are reactants, and they react with one another and turn into a set of compounds that are products. Once we figure out what the chemical formulas for those reactants and products have to be, and once we've written out the unbalanced equation, we can't change those formulas. The formulas cannot be changed once we've written them down, once we've figured out what the formula for each reactant and product must be. So in the balancing part, you can't make changes to the formulas. You can't change those. All right, they have to stay the same. And of course, in a chemical reaction, you don't need to get to create or destroy atoms. All right, so that means that the number of atoms on one side of the equation has to equal the number of atoms on the other side. If you've got two hydrogens in the reactants, you've got to have two hydrogens in the products, and so forth. So the number of atoms must be equal. And when this is true, then you have a balanced equation. So a quick reminder on translating. This is actually one of the ones that we did in class yesterday. Our example with elemental chlorine gas bubbling through aqueous potassium iodide, where you're producing elemental iodine and aqueous potassium chloride. If you turn that into an unbalanced chemical equation like we did in class yesterday, you end up with Cl2 gas plus potassium iodide aqueous produces iodine, elemental iodine, which is a solid, and potassium chloride, aqueous. So if we start with this reaction and say we need to balance this equation, the first thing we do is count atoms. Balancing is really about counting atoms. So let's count. How many chlorines do we have on the left side of the equation? I see 2. Here are 2 chlorine atoms. Okay, remember that. How many potassium atoms do we have on the left side of the equation? I see 1. How many iodines do we have on the left side of the equation? I see 1. All right, keep that in your head. Let's look at the other side of the equation. On the products, I see 1 potassium, 1 chlorine, and 2 iodines. All right, so when we finish with this balancing process, we'll have to have 2 iodines on the right, balancing 2 iodines on the left. And 2 chlorines on the left must be balanced by 2 chlorines on the right. Okay, so we can start in different places when it's time to balance. Let's look at the iodine. You'll see that there are 2 iodines on the right side, but only 1 on the left. That's not balanced. So we're going to add a coefficient in front of the various players here to balance the equations. What does that look like? Where here's a coefficient. We're going to use this 2, and we're going to put this 2 right in front of the Ki. This coefficient 2, and that's actually supposed to be a little bit higher up. The animation is poor, I apologize. The 2 here, this coefficient tells us we have 2 potassium iodide units. All right? And so that means now we have 2 chlorines on this side of the equation, 2 potassiums, 2 iodines, all on the left. On the right, we have 1 potassium, 1 chlorine, and 2 iodines. So at this point, the iodines are balanced. There are 2 of them here because we have I2, and there are 2 of them here because we have 2 copies of Ki. However, our potassium is unbalanced because there are 2 potassiums on the left, only 1 on the right, and 2 chlorines on the left, but only 1 on the right. So we need another 2. Where will we put that one? Well, if you guessed in front of the KCl, you would be correct. So if we put a 2 here, this means we have 2 units of potassium chloride. All right, now let's check to see if the atoms are balanced. We have 2 chlorines on the left, 1, 2, and oh look, 2 chlorines on the right, 1 from each unit of potassium chloride. We have 2 potassiums over here and 2 potassiums over here. We have 2 iodines on the left, 2 iodines on the right. Yes, these things are balanced. So we have successfully balanced this equation. Easy, right? So here are the steps for writing balanced equations. Some of them you saw yesterday when we discussed translating. So the first thing you do is identify the reactants and products, and as you saw from yesterday, that can sometimes be a little tricky when you're reading a sentence and you need to turn it into an equation. Um, Sometimes it's a little tricky to figure out which are the reactants and which are the products. So start there, and I not only identify them, but write out their correct formulas. And it has to be the correct formulas, which means you need to think about, is this compound ionic or covalent? Um, and if so, do I use the ionic naming rules or the covalent naming rules? Um, is the compound balanced? Uh, do I need two calciums to balance my one carbonate, or do I need one calcium to balance my one carbonate? So you need to think about charges, and you need to think about all those rules that we talked about in the last unit. So you write those out into an unbalanced equation, like we did yesterday. And then we add coefficients. These are the numbers that go in front of the compounds to balance the number of atoms. Let me reiterate this because people keep trying to do it. Once you have written the unbalanced equation with your correct formulas, you can't change the formulas at this step when you get to step 3. In other words, after you determine what the formula should be for each compound, and then you're trying to balance the equation, you can't make changes to that formula. The formula has to stick. The only thing you can change is the coefficient you put in front of it. So you cannot change the formulas. And then once you put coefficients in front, you count atoms to see whether they are balanced or not. Now you need to look for atoms in elements, in compounds, and in ions. Sometimes you'll see polyatomic ions. And here's a tip. If you see polyatomics, like the example that I was just sort of tossing off, calcium carbonate, CaCO3, the CO3 carbonate is a polyatomic ion. Keep the polyatomics together. You don't get to take them apart. And you can balance them as a unit. So you can look at the left side of the equation and say, look, the left side has 1 carbonate on it, but the right side has 2. I'm going to balance the carbonates by putting a 2 coefficient in front of my carbonate on the left. We'll see lots of examples of this, and again, I believe that the best way to learn this kind of thing is by working examples. So you have a worksheet to print out for tomorrow. Please do so. I'll have many more example problems for us to do. We will work through them on the board, and you'll get lots of practice in balancing equations, which really, again, just comes down to counting atoms. All right, that's it for now.